Hi there, I'm Chapman, software consultant for Embarcadero Technologies. Welcome to this skill sprint on building RESTful services in C++ Builder. My email address and Twitter handle are on the screen and will be again at the end of this presentation. At the bottom of the slide you can see a link to the blog post which accompanies this skill sprint. This skill sprint works with Windows, OS X, Android and iOS for both the client and server-side applications. We're going to look at how to convert our service into an Zappy plugin for Microsoft's IIS, which of course will be Windows only. The same technique could be used to convert the service into other formats, such as an Apache plugin, for example. The skill sprint is relevant to RAD Studio, Delphi, and C++ Builder, and as you're watching the C++ track, the code will be written in C++. If you missed the Pascal version on Tuesday, you can find a recording on the accompanying blog post or at the Embarcadero YouTube channel. We're going to build a REST JSON service which runs over HTTP. We'll take a very brief look at what REST and JSON are, and for more information on each, you'll find links on the blog post. We'll then look at how to start the server project in such a way that you can choose to build either a standalone application or an Zappy module, or perhaps an Apache module or other. We'll then create the methods of CRUD, create, read, update, and delete, and we'll end the skill sprint with some Q&A time. So REST, or representational state transfer, is an architectural style which shapes your application. Saying that an application is RESTful is something like saying it's an N-tier application or a client-server model. It describes the shape of the application, but it doesn't fill in the details, such as which protocols are used. Today we're going to use JSON over HTTP, but we could just as soon create a RESTful service which uses XML and SOAP, or which runs over TCP directly. Making an application RESTful imposes several constraints on the design, including that the service must be stateless and therefore doesn't maintain information such as a session. The service should also have a uniform interface, meaning that the client doesn't necessarily have to know which APIs or resources are available on the server. It can discover these. The exception to that is known fixed endpoints, and what we're going to build today will have a single endpoint. Typical implementations of REST over HTTP employ a CRUD-like system for manipulating data. We'll use the 4 verbs from the HTTP protocol get, put, post, and delete to represent the various CRUD methods. Now let's take a look at JSON. JSON stands for JavaScript Object Notation and was originally derived from the JavaScript scripting language. Being a language-agnostic format, JSON is now used by a wide range of programming languages as a means of encapsulating data in a readable format. JSON primarily consists of a series of comma-separated name-value pairs, which may be grouped with braces to form objects, and may also be grouped with brackets to form arrays. JSON is also recursive in that any object can own any other object and may own values and arrays also. Here's a piece of example JSON taken from the Wikipedia page. You can see the name-value pairs, and you'll notice that the fields of the address are encapsulated with braces, making this an address object. Similarly, the phone numbers are encapsulated with brackets, and each of the elements inside that bracket is enclosed in braces. So the phone numbers array is an array of phone number type objects. So let's go ahead and start building our server. Okay, so here we are in the RAD Studio IDE. I'm going to get started with our project by selecting File, New, Other, and I'm going to select a web broker web server application. The first one I'm going to build will be our standalone application, and since we want this to be available on all platforms, we'll select FireMonkey application, and then I'm going to go ahead and hit test port, and we're testing port 8080, which is the port that our service will run on. Go ahead and click finish. And the IDE has created a service project for us. So I'm going to go ahead and hit File, Save All, and I'm going to save this off. Now, I'm going to create a directory for the application, and then because we'll be building both server and client, I'll create a server directory. And I like to break my source code down into forms and modules. We're being asked to save the form right now, so we'll go ahead and save form main. Now we're being asked if we want to save the project file. So I'm going to make that employee standalone because we'll be building the ASAPI version 2. And now I'm being asked if I want to save the module, so I'm going to come in and save that as mod main, and then the project file itself, employee standalone. So let's go ahead and test that this all builds. And if we come and take a look under our project directory, server, Win32, debug, there is our standalone project. Now we'll take a closer look at that in a moment, but let's get the ASAPI project installed as well. So we'll go right click on the project group, select add new project. Again, we're choosing a web broker web server application, and we're going to choose an ASAPI dynamic link library. Now we've got a choice here of VCL or FireMonkey application. Because this is an ASAPI, it should really be a VCL application. But if we do that, we'll get a warning when we include the module from our standalone saying that the standalone project is built for FireMonkey and the ASAPI is built for VCL. Now you can safely ignore that warning, it'll all still work, but I'm going to go ahead and select FireMonkey and just avoid the warning altogether. And click on Finish. So we now have this IIS ASAPI project, and a default web module has been created for us. I'm going to remove this web module from the project, and then I'm going to add in the module that we created for the standalone project. Okay, so what that's done is it's now caused my ASAPI project to share a module with the standalone. So as I test and debug and build out the standalone application, so long as I put the changes into my module, those changes will be reflected in the ASAPI as well. Let's go ahead and save all of that off. So the project I'm going to call employees, and the project again, employees. And now I'm being asked if I want to save the project group, so let's go ahead and call this group employees, and there we are. So I'm going to go ahead and build all, and we have a successful build of both. So if I go and take a look in the project directory, under Win32 I now have my standalone and also this Windows DLL. Now, interestingly enough, Microsoft's IIS only allows 64-bit applications by default. It can be configured to allow 32 as well. So I'm going to go ahead and add the Windows 64-bit platform to my IIS project. And I'm going to hit build again. And so now what I have under my Win64 directory is a 64-bit version of the ASAPI DLL. Okay, so let's go and take a look at what we've got here in the standalone application. We have our main form, which is the form that we've seen for starting and stopping the standalone service. We don't really need to modify this form at all because we're not sharing this between the two projects. We're sharing the module. So we'll make our code changes to this module. If we take a look at the module, it has a list of actions associated with it. And if we take a look at those, the default action is pre-populated for us. You'll notice that the default handler has pathinfo of /. This is the root path on our HTTP server. So if I go ahead and run this application, start the service, and hit open browser, it'll navigate us to localhost port 8080, and it returns this content web server application. So if I go and take a look at the default handler, it has an event for onAction, and in the event we can see that it is returning web server application wrapped around a little HTML there. So let's take a look at the parameters that we have here. We've got a tweb request class, which is passing in the HTTP request. So this is going to carry the content of the request, the parameters, and it'll also tell us which HTTP method was used when making this request. We have tweb response, which we're actually using here to send our response content back to the client. And we have a bool called handled. By default, handled is set to true. And what this means is if our handler code here handles the request, then we leave handled as true, and the application knows that this particular HTTP request was handled. And the reason this is important is because we're going to add a new action with add item. And this creates web action item 1. I'm going to rename this to ACT employees. And then I'm going to set the path info to /employees. And what this is doing is it's creating a new endpoint, this employees endpoint. So let's go ahead and put some code behind this. Under the onAction event handler, I'm going to put in response content equals, and we'll just send back the employees tag for the moment. Now again, handled is true. If handled was set false at any point during this method, we would fall over to the default and return web server application. But we're going to leave it true because we're handling this request. I'm going to go ahead and save all and run this application. Now when I start the service in open browser, it's going to bring me back to the default handler. I'm going to add /employees. This takes us to our employees endpoint, and we get the employees tag come back. So that by itself isn't incredibly useful, but before we flesh this method out, let's go and take a look at building the client application. I'm going to right click on my project group again and add a new project. This time I'm going to select a multi-device application. So this is an FMX blank application which will run on any of our supported platforms. Now what I'm going to do with this, I'm going to go ahead and save the project off. And this time I'm going to create a new directory for client. And again, I'm going to create a forms directory for my forms and save the main form as form main, which will not conflict with the server application because it's in a new project and a new directory. So we're fine to name those the same. And I'm going to go ahead and save the project as employee client and do the same with the project file. Okay, so we now have this client application and we can make use of some of the REST classes that come in the IDE. So I'm going to put in a REST client. I'm going to put in a REST request and a REST response. So the REST client is effectively your HTTP client. I'm going to go ahead and take the little one off the name there. And this is responsible for making requests against the HTTP server. The request that it makes will be represented by this REST request class. Again, remove the little one there. And this is going to carry the content and parameters of the request up to your server. When the server responds, that'll be represented by this HTTP response class. Again, we'll take the little one off. And this is going to carry the content of the response back from the server. So what we need to do here is just make sure that the REST request class is correctly set to the REST client and to the REST response. Then on the REST client, we want to put in our base URL, which for our standalone service is localhost 8080. Now, if we were running against the ISAPI, we could take off the 8080 and run it on our local host, or we could change the URL to reflect where the IIS server is sitting. Under the request, I'm actually going to put in under the resource property here /employees so that we get our endpoint. Now what I can do, if I make sure that the application, the standalone, is running, I can go ahead and on the client application execute this request in the designer. I get back a response 200 OK, and my response class now contains some content. We can see 15 bytes here, and the content is the employees tag that we put in on the server. Let's go ahead and put something more useful in the server's response. So we'll close down this application and we'll go and modify our event handler in mod main. Now I'm going to use a little bit of copy-paste code here. So I've got some code here which is setting the handle property to true. It's kind of an irrelevant setting at this point, but I just like to make sure that that's correctly initialized. And then I have a switch statement which is looking at the method type from the request. And so if I get a HTTP GET request, I'm going to call the employee GET method, put request, employee put method, and so on. So what we're going to do first of all is flesh out these methods. So before we start fleshing these methods out, I'm going to go ahead and come back onto my module, and I'm going to go across to the Data Explorer, and I'm going to grab an interbase connection to the sample employee database to the employee table, and I'm going to drag that into my module. The connection I'm going to rename to con, save myself a little typing, and the table, which is actually a TFT query, I'm going to rename this to QRY. So now if I click connected true and active true, my module now contains a connection to the employee database and to the employee table. Now if I switch back to the projects, I'm going to go ahead and build all. And you'll notice here that we have an error when linking the ISAPI. And that's because we've added the FireDAC components in, but we've not modified the project to contain the dependency. So if I go ahead and open the project, the same module under the ISAPI project, and then hit build again, now we can see that the project builds correctly. So back in our standalone application, we're looking at the employee get method, and once again I'm going to use a little bit of copy-pasted code here. Okay, so what I'm doing here is I'm checking against the HTTP request class to see if there are any fields. And I'm actually just checking if the count is greater than 0. I should probably check specifically for 2. And the parameters that I'm looking for are min and max. Now if I have those parameters, I'm going to select from the employee table where the employee number is between min and max. If I don't have any query parameters, then I'm just going to select star from employee, so I'll get everything. I'm then going to set my query to true, and assuming I get records back, I'm going to start building a JSON array. Now this JSON array is going to carry all of the records that we get returned from our query. So I start by selecting the first of those records, and then I'm going to do a while loop through all of the records. And for each one, I'm going to create an object which represents that record, and then I'm going to add each of the field values, employee number, first name, last name, and so on, as a JSON pair on that object. Then what I'm going to do is add that object to the array and jump over to the next record. When I'm done looping through all of the records, I'm going to set the response content type to application/JSON. And this is actually a REST requirement that you send back the information about what the format is so the client knows what to parse. In this case, it knows to parse JSON. We're then going to set the response content as the array to string. So we're going to convert the content of this JSON array into a string and return that as our content. So let's go ahead and run this service. I have an error. What have I done wrong here? Unified symbol JSON. Okay. So what I needed to do here is include the system.json namespace. Let's go ahead and put it right here. Include system.json.hpp. Okay, and run the service. Good. So if I click on start, my service is now running. If I open that in my browser, I can browse to our employees endpoint, and this is the JSON data being returned in a JSON array. So let's go and modify our clients to work with that. Execute the REST request, 200 OK, and then the REST response actually has a little over 8,000 bytes of data, and that's our JSON data. Okay, so we've implemented the CRUD read method. What I'm going to do now is put you on pause, and I'm going to go ahead and flesh out both the server and the client application, and then we'll take a look at each of the other CRUD methods. Okay, so I've gone ahead and I've fleshed out the application, both the client and the server side. And one of the things I noticed while I was doing that is because we're building a 64-bit version of the ICE API, we're not able to use the classic Borland C++ compiler for that. So what I've done is in the standalone executable and in the ICE API project, I've gone ahead and disabled the option for using the classic Borland compiler in 32-bit modes. And that's here under C++ compiler, classic compiler, and I've basically disabled that for both of the projects. So now both of those projects are using the Clang-based C++ standards compliant compiler. In the client application, what I've done is I've created a couple of variables up here, JSON array and current index. So this form now has an array of JSON objects and an index into that array. And then this method, JSON to form, if we go take a look at the implementation of that one, simply copies the values from my JSON array. There it is. Copies the values depending on the index that we have selected into the edit boxes. So whichever item we fetch from this array, we're just using get value to get that value and put it into the edit boxes on the form. I also added, as you might have seen me scrolling past, a clear form method which will clear the text out of the form, and then 3 mode methods. So we have a create mode, which will set the read-only properties of the edit boxes to false, and will alter the text color to red. So this is going to be the mode that we go into when we want to create a new record. I also have browse mode, which makes all of my edit boxes read-only and sets the text color to black. And then I have an edit mode, which is going to set all of those read-only false again and set the text color to blue. So those 3 modes are going to let me browse, create, edit, and delete records. So let's take a look at how we implement the read method, because you've seen me read data using the REST client and REST request. But how do we get that data into our form? Well, what I've done here is in code, I've manually said I want to connect this REST request to the employee's endpoint. I've then set the HTTP method to get, and I'm just making sure that my response class is bound to the request. Then what I'm going to do is I'm going to create a couple of parameters. So I'm adding a minimum and maximum parameter to the request. And I'm getting those values from these 2 edit boxes here at the top of the form. So this is going to let me select between the min and max employee number. I then call the REST request execute method. And then I clear out the JSON array that I have stored in the form's private global. And I'm using this tJSON object parse JSON value method. And what that's going to do is it's going to parse the content that I get back from my response and create a JSON object which I cast as a JSON array. And I then set the index that I want to view in that array to 0, and I call this method JSON to form, which is going to load the first entry in the array onto my form. So let's go ahead and see that one running. In fact, I'll just start up the server. Okay, so my server is running, and here's my client. So what I'm going to do is I'm going to set a high number, say 10,000, and hit the read button. So I'm now getting all of the employee records from the data table where the employee number is between 0 and 10,000. Now this previous, next, first, and last buttons do nothing more than alter the index according to the entry that I want to look at in the array, and then call JSON to form again so that it loads that data into my edit boxes. Okay, so having looked at the read method, let's go ahead and see the create. Now the button doesn't actually call any REST method. What the create button does is it clears the data from the form and then it enters this create mode. Now that's going to set all of the text boxes to red, if you'll recall. It'll also enable this button, the commit button. And it's on the commit button that I'm going to make my REST call. So here I'm saying, again, set my endpoint to employees. I'm using the post method because I'm doing a create. And I'm making sure that I'm able to receive a response. Now what I'm doing here is I'm using this body property of the REST request, clearing that out and using its JSON writer to begin writing a JSON object. And then I begin writing a property for that object, in this case first name, and I insert the value from my edit box, and then I do the same again for last name, phone extension, and so on. Now the one thing that I'm not doing here is I'm not inputting an employee number. And the reason for that is when I insert this record into the database, an employee number is going to be created for me, so I don't want to send one up with the request. Once I've written all of my values into the body of that request, I'm going to call this write end, which is basically going to close the JSON object. I'm skipping the form back into browse mode, ready to receive data back from the request, and then I execute that request. When the server has done what it needs to do, it's going to send this object back to me, but it's going to include the employee number as a new parameter in that object. So what I'm going to do is I'm going to clear out the array that I have in my private member, and I'm going to parse this JSON content back into that array. Now this will be an array of one entry, so I'm going to set my index to 0 and load that entry onto the form. Before we see that run, let's go and take a look at how that looks on the server side. So in my module, we're looking at the post method. So what we're doing here is the object that I built in the request body is now being parsed, again using parse JSON value, and that's being stored as a local reference to a request object. So that's the object that I sent from the client up to the server. I'm then building up this insert statement for my database with my query, and I'm then going to populate each of the fields, each of the columns, with values taken from the request object. So we're going to put in the first name, last name, and so on. I'll execute that SQL query, and the employee number will be set for me by a generator. That generator is the EMP nogen generator. So I'm then going to reset the query and ask for the current value of that generator. That value I'll store in new record ID, and then I'm going to take the request object and add the employee number, which would be new record ID. And then I'm going to build a JSON array with a single object added to it. And again, I'm going to set the content type to application JSON and return the array as a string. So let's go ahead and see that method run. What I'm going to do here, I'm going to start by requesting those records again. So I'm going to request everything and go to the last record. We can see the last record is for Mark here. So I'm going to create a new entry. This will be Craig Chapman, and because the employee database has some constraints, this would be ENG 3 USA and 50,000. So then when I click commit, that packet gets sent up, immediately comes back down. We've entered back into the browse mode, and that data is being displayed. So if I hit read again and request all of the records, and this time hit the last button, I'm now looking at my new record. So let's go ahead now and take a look at how the edit mode works. Again, clicking on the edit button does very little. All I'm doing here is setting edit mode, which in this case is going to set the text color of each of the boxes to blue. It'll also enable this update button, and this is where I'm going to make the update REST call. So again, I'm selecting my employee's endpoint. I'm using the put method. And this time I'm clearing out the request body and building up the same JSON object, but you'll notice that this time I'm including the employee number. And that's because this employee number is what's going to identify the record that we're going to alter. I'm also sending all of the values up regardless of whether or not they've changed. And on the server side, to keep things simple, I'm just going to insert all of those values, or rather alter all of those values in that record. Then I enter back into browse mode, execute the request, And as a response, this method is just going to send back the JSON object that I sent to it. So we're going to clear out the JSON array and parse the response value. Again, go to entry 0 in that array and load that entry onto the form. Looking again at the server side, this time we're looking at the put method, which is right here. So again, we're taking that object which is being sent up from the client, so we're parsing that as JSON. We're then going to modify the query component to be an update statement, and I'm literally updating all of the columns except the employee number, which is my predicate here. So I'm going to go ahead and put in the values from the request object, execute the SQL, and then I'm going to build a new array with a single entry, which is my request object. So I'm just posting that request object back to the client, set my content type, and send the array. So again, let's go and see that method running. I'm going to go ahead and request all of the records. And if I go to the last record, you'll see now it's Craig Chapman. So I'm going to hit the edit button for edit mode. I'm going to change my name to blogs and hit the update method. Now that has already sent the request up to the server, which has altered the content and sent the object back as a confirmation. So if I hit read to refresh my results and last, we can see that I'm now Craig Blogs. And the final one of the 4 CRUD methods would be delete. So in this case, I don't need a mode button because I'm just going to delete whichever record is currently displayed on the form. So what I'm doing is I'm creating maybe a bit of errant code there. Let's remove that. So I'm making a request. I'm setting the endpoint to employees. I'm setting my request method to delete, and I'm making sure that my response is bound. Then I'm going to send up a parameter, and the parameter that I'm going to send in this case is the employee number, which I'm taking straight from the form. So whichever entry that I'm looking at, that's the employee number that I'll be sending. Now I'm not sending any JSON content here. I'm just sending up a HTTP request parameter. So we go ahead and execute the REST request, and as a return value, the server should send back an object which contains nothing but the employee number, which is the employee that we deleted. So I'm going to parse that response from the server. I'm going to open up the 0 entry in that array and read out the employee number, and this will tell me that this is the record that was deleted. I'm going to send that in a show message. Then I'm going to clear my form and go back into browse mode. So let's go ahead and take a look at how that's implemented on the server. So we have the delete method here, and as I said, I'm not sending up any content in the request. Instead, I'm sending a parameter or a field. So we're going to read that field value, and that gives us our employee number. Then we're going to set the SQL statement to delete from employee where employee number equals, and we pass in that number that was sent as a parameter. Then I execute that query against the database, and I'm going to create a new array and a new object. The new object has a single pair, which is the employee number. We add that object to the array and return it as we have before. Let's go ahead and see that method running. I did need that object. I'm just using it much further down. Then why am I not putting that? There. Okay, let's try that again. Okay, so I'm going to go ahead and read all of these entries, skip along to the last entry, and this is Craig Blogs. My employee number is 147. So I'm going to go ahead and hit the delete button, and it'll tell me that I've deleted record 147. And then if I read all of those entries again and skip to the last record, we're back to Mark because that record has been deleted. Here are some additional links, the first of which is to the blog post that accompanies this skill sprint, where you'll find all of the other links and more information. I've then included a link to my blog where I discuss using the JSON classes in both Delphi and C++ Builder. We've then got the Wikipedia links for REST and JSON for some additional reading. We're almost ready to open up for some Q&A, but first, let's listen to a word from Jim on our promotions.
Give me a brief moment to tell you about this limited time special offer. All 10 Seattle registered users get the bonus pack, which includes the new Object Pascal Handbook by Marco Cantu. This essential language reference is a modern language guide that includes new features of the language and the core runtime library, a must-have for any Delphi developer. Also get the Binder Converter Basic. It handles the heavy lifting when converting existing VCL applications into FireMonkey applications, so you can start taking advantage of multi-device development right away. And the Premium Style Pack includes premium styles for VCL and FireMonkey to make your application look great on every platform. For more information on these special offers, or to find out what the current offers are, please visit www.embarcadero.com/radoffer.
Your next skill sprint will be on using animations and effects on components. The Delphi track will start on the 9th of February and the C++ on the 11th of February, each of which will be at the times listed on the screen. That concludes this skill sprint. Thank you for watching, and I'm now going to open up for some Q&A.
So I thought it was a really useful skill sprint. I thought you did a great job explaining REST and JSON, and I love the way you pronounce JSON, by the way. I'm not sure what it is about that, but I appreciate it.
I try to keep it as brief as possible because JSON, REST and JSON can be quite heavy subjects and quite in depth. But what matters is that the REST is the architectural style and JSON is the encoding, and as long as you get that, then you understand how to separate those concepts.
Yeah, I like that you compared REST to being like saying it's an in-tier application, because that's a good description, because a lot of people think REST is very specific, like SOAP Web Services, right? There was a very specific implementation of that, but REST can be a lot more vague.
That's right. So I've got one question here. Any comments on security for the REST transfers? Yes, what I didn't put in the demonstration there was there are two places. On the standalone server, during the project creation wizard, you're able to select HTTPS in there. Now, I tend to not use the standalone server for production applications. For that, I would use an ISAPI or Apache module, which plugs right into the HTTP server, and then I configure the HTTP server to give me HTTPS. So I effectively let the web server do what it's good at doing and provide the encryption for that transfer, which is why I didn't enable it anywhere in this demonstration. Now, the standalone application I would use for development and debugging purposes, and in which case I might at some point want to use a HTTP debugger, and I certainly don't want to have the traffic encrypted then. I want to be able to see it, so that's why I left that disabled. I would also say I didn't put any code in one of the questions we had earlier in the week. I didn't put any code in here to test for SQL injection techniques. You can do that by pre-validating the body before you send a HTTP request and pre-validating the content that you get back from the response. But I didn't put anything in the demo for that purpose. That would be an exercise for the reader, so to speak.
Good points there. What editions of C++ Builder do you need to write this? Professional, enterprise, or what?
Okay, so web broker services can be created in any edition, professional or higher. I couldn't tell you about starter. I'm really not sure what's in that, but professional or higher. And the REST parsing classes were introduced, I think, in XE6. So it would have to be XE6 or higher for the REST classes. although there's no reason in earlier versions why you couldn't write your own JSON parser if you felt so inclined. So professional edition at least would be what you'd need.
Yeah, there were some improvements in the JSON libraries in the last couple of releases as well, so that's useful. Let's see. Oh, another question on HTTPS. Thank you for a useful presentation. Yes, very good stuff here. Lots of great
More
stuff.
than welcome.
And, I believe you have the code available to download here on your webpage.
Yep, source code's available, the original recordings, and the slides as well for anyone that wants them.
Excellent. So, I was watching this and I was thinking, what would be useful is if I had a method where I could pass a record or a data set and have it give me JSON back. So I didn't have to do that, creating the JSON every time.
Well, actually, one of the reasons why I implemented each of the methods separately for the CRUD methods is the only real difference between them is the endpoint. So in theory, because when you look at the JSON object, you can enumerate the attributes of that object. It's quite easy to do. So basically, you could take those 4 methods and implement your own class for both server-side and client-side, on which you just set the endpoint, and it takes care of the rest for you. So you could save yourself a lot of repetitive work just by bundling that up into a class. Wouldn't even require any RTTI to do that. So that's one object, and that's why I separated out the CRUD methods for the demos, just to demonstrate that here's how you'd write each one of them. You can go ahead and use them as you see fit. So.
Okay, very cool. All right, well, great. Thanks everyone for joining us today. Hopefully, we'll see you back next week when we talk about animation and effects. Oh, actually, there's one more thing I wanted to show here. We do have a new special offer going on right now. Embarcadero/red offer. So they added a new special offer since we recorded this video. We have a buy one, get one offer going on right now. So if you buy any one of our tool, you can get another tool for free of equal or lesser value, so not any tool for free. If you can come out here and check it out, there is a list of what this applies to. Do come out here, check out the terms and conditions, frequently asked questions, and act now to take advantage of this special offer. You can always find the current special offers at embarcadero.com/rad offer. How can I enumerate through the headers in a T-Web request?
Okay, so the T-Web request class actually parses most of the headers for you and puts them into the relevant properties. But if you want to get direct access to the headers, then the raw content property will give you access to that string. And as is typical with HTTP headers, it's name value pairs. So it's not too tricky for you to go in and parse out that data yourself if you have a specific attribute that you need to get to.
Now, in the response the server sends, can it send custom headers as well?
That is a good question. I believe you can. You can actually send custom return codes if you want to, and put your custom headers into the response. I'm not sure why you might want to, because honestly, you would just put the content that you want into the content property and send that.
I'm just curious.
I mean, one of the so for example, you saw that I used a parameter there for the delete method instead of sending it as a JSON object. And the reason for that is if you go and read the HTTP spec document for any version after 1.1, the delete method actually doesn't have a content body in the specification. There's nothing in there to say that it can't have one, but there's no specific specifier saying that it must be there. And as a consequence, some servers support it and others don't. And this is one of the reasons why when we do the REST system, we're using the parameter because it's guaranteed to accept the parameter but not the body.
Okay, great. What's the best way to implement security when building a REST server?
So you can, it's basically HTTPS. So as you're creating a standalone project, there's actually a checkbox in the wizard for HTTPS. Now, I developed the standalone project there as a development build. It's basically for debugging. And if you're going to use, you could use this standalone as a production server. It's quite stable, but it's not incredibly scalable. And it's not a professional HTTP server in the same way that IIS or Apache are. So if you want to implement security, my advice would be to build either an Apache or IIS module and use the security features of that HTTP server. Just enable HTTPS and whatever else that you want to do for the security. And as a side note, we were asked in a previous airing of the sprint if I'm doing anything to prevent against SQL injection in my code, and I'm not. In the demonstration, I'm doing nothing to prevent SQL injection. If you want to do that, then you simply go into the content or body property of the request or response, depending on which way it's going, and you can do a search for, say, semicolons or quotes or whatever might be used to do the SQL injection attack. So you can parse that out for yourself, but I'm not making, I've not made any effort to do that in the demonstration code.
Although if you're doing parameterized queries, then that would also fix it, because SQL injection occurs when you concatenate your strings, if I remember correctly. But yeah,
that's right.
Definitely keep an eye on that. Another question here. If you use HTTPS, does that encrypt all the data that's sent back and forth, or just the URL that's being...
My understanding is it doesn't actually encrypt the URL, it encrypts everything else. So it encrypts the body and the headers that are sent back and forth. That's my understanding of how HTTPS works.
Yeah, I believe the URL is actually sent in the header, so you only have the IP address is the only thing that's not encrypted.
Yeah, so the URL, or it's actually broken down in most, excluding HTTP protocol version 1, which basically a version 1 server could only host one site, but in version 1.1 or 1.2, they introduced this additional header in which you put the URL, and basically it's broken down into the base URL, or the top-level domain, and resource path. And the reason for that is so that one HTTP server can recognize that a request is being made for one of several domains hosted by the same server, and that would be encrypted by HTTPS because it's contained within the content or the headers of the protocol.
Now, on the client side, do you have to add certificates, or how does it able to decrypt it on the client side?
Again, I'm kind of vague on the implementation details of HTTPS, the way that works, but my understanding is that the server has generates both a public and private key, and your browser accepts the decryption part of that key in its first request. Now, if that key is generated by a certified certificate authority, then that's the most secure option. And of course generate a private key for yourself. That will generate a warning in the browser for your user saying, this is not a certified authority that generated this key, but if you're using it within your own corporate walls, then it's acceptable as a form of encryption.
Yeah, I will add here, Ahmed, and you're asking a few questions about encryption. Definitely you want to make sure you understand encryption before implementing anything, because it is a very complicated subject, and so definitely do a lot of research on this. But so my understanding of the way encryption works is that the server has a key, and then the client validates that key using the validation chain, like Craig was saying. But then what happens is it does a key exchange, and so it gets the public key from the server, uses that to generate a one-time use key, which it then validates against the server. And since the server has a private key, the client can encrypt the key to the server using the server, and only the server can decrypt it with its private key. Once that's done, it uses this one-time key in order to encrypt the session. So as long as your server has a valid certificate, or a certificate that you're able to validate, or a certificate you're just willing to accept, then yeah, it's able to encrypt the data back and forth using just the server's key. The server key usually is generated with RSA, which is a public key encryption technology, and then the data transmission is typically done with AES or Rindal, which is a private key encryption technology, and that private key is generated through that key exchange. But again, that's high-level summary. Definitely do more research on this because you don't want to implement this and miss something. That's one thing about encryption is you can have some secure libraries and think you've gone through all the process and realize and totally miss something and end up having a vulnerability in your encryption. So it's better to research it extensively than to think you know what you're doing and find out you don't later.
So I can give one very quick example of how you can fail very easily in security terms. Using this technology, I used to build quite a lot of web servers. It's not just for REST, the web broker technology. And one of the common practices at the time was to encrypt a password on the client side using a MD5 hash, and to send that hash up to the server so that somebody sniffing the HTTP traffic couldn't read the password in plain text. Now the problem is, if that person is sniffing that traffic and they grab that MD5 hash, that is as valid as the plain text password. So that was not a useful technique. With HTTPS, things are an awful lot better. My understanding is the key is effectively generated by the product of two randomly selected prime numbers, and if you take the product of two primes and try to reverse engineer it to find the original two primes, it's very, very difficult to brute force that mathematically. And so one of those source primes is used on the server and the other is used on the client, and by putting the two pieces together, the server is able to decrypt the traffic. But definitely do a little research on how HTTPS works and how to implement it before trying to deploy anything as a production server.
It seems like I remember reading something. There's actually like the default installation on IIS when you're doing HTTPS includes like this old version of HTTPS that's known to be full of vulnerabilities. But if you don't go in and disable that manually, then your HTTPS connection is very vulnerable because of that old version that's still supported. So yeah, definitely something you want to make sure you're very well educated on or consult with somebody during the process.
I'd also add one last point, just because you mentioned the potential vulnerabilities in IIS. There's similar potential vulnerabilities in Apache because Apache is using, I believe it's still using OpenSSL, and of course we saw the Heartbleed issues last year. Depending on your build of Apache, you might want to check into that as well. So.
Yep. Yeah. Yeah. Okay. Well, fantastic, Craig. This has been a tremendous skill sprint. Lots of great information in here on building RESTful servers. Here's another question. How can I upload a file to a web module from the client while TWeb request doesn't have a content stream property? So send more than just a little bits of data, but send a whole file.
Yeah, and frankly, probably the best way to do that would be to take the binary data as a stream and encode it as base 64 and put the base 64 encoded data into a JSON array and send that, but don't send it all as one piece. Break it into chunks of a given size, maybe 512 bytes or so, and send it as chunks. Now that's going to work in pretty much the same way as a web server would do this transfer anyway. So if you put something into a content stream, for example, all that's happening under the hood is what's called chunking encoding, which is just breaking it down into binary chunks and sending it up. So that's how I would suggest doing it. And I believe you can do that at the HTTP level. It doesn't have to be inside of a JSON array, but going off of what we looked at today, it would be a JSON array.
And does Apache work on Windows or just Linux?
Apache works on Windows, Linux, Mac, and just about any other platform you can think of. Basically, if you're looking to set this up on Windows or Linux for the first time, then what you want to do is search for either LAMP for the Linux side, LAMP, and on the Windows side, search for WAMP, WAMP. So those stand for Windows, Apache, PHP, and MySQL, I believe, and again Linux, Apache, PHP, and MySQL, because those packages will have an installer that will be quite straightforward out of the box to get you up and running with the Apache server.
I think, doesn't Microsoft have a thing that will actually deploy Apache for you? They had like this web installer or something a while ago. It seems like I've seen some web installers that will install the whole WAMP stack for you so that you're ready to go.
I don't know that it will. I think the web installer from Microsoft will install PHP, MySQL, and a whole raft of other things, including WordPress and CMSs and stuff.
That's right, but not Apache. That's right.
But I don't believe it'll give you Apache, no.
Here we go. Here's one. It's called Bitnami that will install the whole WAMP stack for you on Windows. So check that out. There's a few of those out there that will install your whole stack for you. But again, make sure you understand all the pieces and parts that are in there, especially if you're planning on encrypting it. So that's important. Okay. Which is faster, Apache or standalone DataSnap server?
That really depends on the environment you're in. So the DataSnap server is very, very fast if you're talking about a smaller number of clients and you're just making straight HTTP request and response. If you're talking about going to the level of very high numbers of users or going to maybe even multiple servers, load balancing over Apache. Apache has built-in functionality for load balancing and for so more than 1,000 clients I see there. I would suggest, if you can, build this as a module for an Apache or an IIS server because you'll get the load balancing features and you'll get caching of. So if you have, say, 100 requests come in at once, DataSnap will try to sequentially process all 100 with as many threads as it has running. What Apache will do is it will cache some of the resulting data, and it'll do clever sort of scheduling things to schedule those to get responded to in the quickest possible order. So yeah, if you're going for 1,000 clients or more, a professional HTTP server as a host is not a bad idea.
Yeah, I know Marco Cantu published a paper a while back that I'm sure it's around someplace that he says that if you're doing DataSnap and you need scalability, use IIS. And I think this was before we added the Apache module support. But I would say definitely, like Craig said, use a professional web server and create it as a module because that web server can then add its all its performance features and things like that on top of that. So that's your best way to go is use a professional web server. And yeah. Okay, I think now we've answered the questions. Hopefully another one of them just come in real quick. Thanks to you so much, Craig, for putting this together and answering our questions today. And we'll look forward to, I guess you have one more today. If anybody's got questions that maybe comes up and they didn't get answered, we can come back and catch us again here at later on today. Otherwise, everybody's welcome to join us back next week for our next skill sprint on using animations and effects with FireMonkey.
Great, thank you, Jim.
Thank you. Thanks everyone for joining us, and please tell your friends to come back and join us next time. Thanks. Bye.